Hi, I'm NAB, Unit 2, Outcome 2, and it's the basic integration section. We have 3 questions to complete here. They're out of a total of 14 marks, and you're required to pass 10 of those to be able to pass the integration section or pass the outcome. Right, let's start with question 3. So question 3 is the first one that we're going to have in this outcome. And what I've got is I have to evaluate an integral. Okay, so I can't integrate that the way it's sitting. I've got to write it in integrable form. So what I'll do is I'll have my integral sign because I've not integrated. I'm going to bring the x to the power of 3 up to the top, and that will give me x to the minus 3. So I've still not done any work there. I've just prepared it for integration. What I'll do then is I'll just go forward and integrate that. Okay, so what I've got here is I've got 5x, I'm going to raise the power by 1, so that doesn't go to minus 4. Remember, raising the power will take that to minus 2, and that's all divided by minus 2. Because I don't have any limits, what I'm going to do is I'm going to add a constant of integration onto that there. I'm just going to do one more final part, and I'm just going to tidy it up with the minus signs. So what I've got is I've got a minus 5 over 2 x to the power of minus 2 plus c. And that's that question complete. Let me show you how to mark that just now. So what I'm going to do is I'm going to get 1 mark for preparing it or for presenting it in a form where I can integrate. I'll get 1 more mark for getting this part here correct, for integrating it correctly, and 1 mark for adding the constant of integration. So that's out of 3 marks, that question there. Right, I'll go on to question 4. And question 4 is a calculation that I've got to do to work out the shaded area. Now I've got quite a lot of information on the graph there, so that's going to be able to help me out work out the answer to this problem. So the shaded area is bounded by the equation that I've been given, and it's also really bounded by the x-axis. And if I look at the x-axis, that would be our x-axis that would run along here. And the formula, the equation of the x-axis is y equals 0. So that's what it's bounded by. And if I was going to write that out in full, I'm going to write down the area is going to be equal to. Right, so to work out the area, we're going to integrate. So I'm going to have an integral sign. I'm going to look at the limits that I've got here, and on the graph I've been given the limits. So my limit there, the top limit that I've got is 5, so I'm going to put a 5 up at the top here, and my lower limit down here is minus 2. Right, from there I'm going to look at what I'm going to integrate, and I'm always thinking about coming down from the top, and the bit that's holding the top of the area in is the equation of the curve. So what I'm going to write down first of all is 10 plus 3x minus x squared. And the bit that's holding it at the bottom, right, this one here sometimes doesn't have to be written in. I'm just going to write it in so that you can see what we're actually doing. And that was y equals 0, so that's the other equation there. And I'm just going to write dx with respect to x at the end. So I've started writing out the way I'm going to work out this area. I'm going to just tidy this bit up, and this is where you may be starting. And all I'm going to have is I'm going to have 10 plus 3x minus x squared dx. Okay, and that's my starting point there, really. From there, what I'm going to do is I'm going to just go straight and differentiate it, integrate it, because for integrating here, everything's prepared for me. I don't need to do any further work on that. So I'll start with a square bracket, and I'll integrate 10. So 10x plus 3x squared all upon 2 minus x cubed all upon 3. And the limits there I'm going to write at the far end here. Okay, so remember what I'm doing is I'm taking the x value that's there currently, so that's 10x to the power of 0 that would be sitting there. Raising the power by 1 gives me 10x to the power of 1 divided by 1, so that just gives me 10x. 3x to the power of 1. Raise the power by 1 makes me up to 2, and divide it by 2 there, and so on. So that's me got that integrated to there. Next thing I'm going to do is I'm going to substitute my values in. So the values are going to be my limits here, and the first one I'm going to put in where x is, I'm going to put the top limit into there. Right, so the first bracket I've got I'm going to be putting the 5 in here. The next bracket I've got here, I'm going to put the minus 2 in there. Right, so that's going to be 10 times 5 plus 3, and in there I'm going to put the 5 wherever I see x squared all up on 2 minus 5 cubed all over 3. Wee bit tight there. I'm then going to put the lower limit into this one here, and I'm subtracting this. So that's going to be 10, and I'll have minus 2 in there. I've got plus 3 times minus 2 squared all up on 2, and minus, that's going to be minus 2 cubed all over 3. So all I'm doing is I'm using this formula here in that bracket and in that bracket, and in there I substitute the top limit, the upper limit, and in there I substitute the bottom limit or the lower limit. From there what I'll do is I'll work this through. I could fire that straight into my calculator and get an answer, as long as I know what I'm doing with my calculator. What I can do is I can write out what that would be if I just worked that through without a calculator. So that's going to be 50 plus 75 upon 2. Okay, so that's going to be 25 times 3. And let's see, what have I got here? I've got minus 125 over 3. I'll close that bracket. I've still got a minus sign there. I'm going to evaluate each of the brackets first before I complete the work. So that's minus 20 plus 6, and at the end there I've got plus 8 over 3. So I'd be careful with that one, because that's minus 2 cubed will give me minus 8. I've got another minus sign there, so that's why that becomes a positive sign there. Okay, and let's go from here. Gathering this part up here, I've just used the calculator to do that, and what I've got is 275 over 6. And what I'll do is I'll take away from that, it's a minus 34, and that's all over 3. Finally, what I can do is just do that in my calculator, and that gives me my answer. But you can go straight from there to there, as long as you're clever enough and with the calculator use. So that should give you 343 all over 6, and that's the area. And what I'm going to say is, I don't know what units were used, so I'll just say it's units squared, okay, for the units. And that's that question complete. Let's have a look at where we're going to get some of the marks for this. Okay, so I'm going to get 1 mark for knowing that I've got to integrate. Okay, so what I'd like to see is an integral sign and something else appearing in here as well. And I would like to see this dx at the end, although that won't be penalised, but it is a bit of bad form. What I'll get next is I'll get a mark for setting up this correctly here. So I'll go down to this one here. So I did mention about the 0 at the start. You don't need to put that in. This is where we're going to get our mark for this part. I'm going to get 1 mark for integrating correctly. So that will be the 3 terms being integrated properly. I've got 1 mark for substituting the values in. Okay, so for this line here I'd get a mark. And finally, for being able to work out the answer is the other mark. So that's 5 marks that we've got for that question there. Right, let's look at the final question in this outcome. So this is question 5. This here is a question where I've got to find out the area between a line and a curve. Okay, so again, I've been given a lot of information here that we would not normally be given in a normal exam type question. So I'm just going to use the information that I'm given straight away. So what I can do is I'm going to work out the area. So my area is going to be equal to, I'm going to integrate, and remember it's the integration section, so remember to integrate these. I've got some limits, so if I look at the limits that I've got, sometimes I might have to work out that point there and that point there, but they're given in the question. So that's 0 and that's 3. Okay, so the upper limit is 3, so that's going to appear up at the top, and the 0 is going to appear at the bottom. That's how I set up my limits on the integral sign. What I'll then say is it's going to be the upper equation, so I'll say upper minus the lower equation. So it's that equation there of that blue line, and the lower is the equation of the curve that I've been given up at the top there. And it's all with respect to x. Right, so let's substitute our equations in. Here we go. So I've got the 3 and the 0. The upper equation is the one that I'm thinking is holding the top of the area. So the one that's at the top of the area was this curve here, and it's not really a curve, it's a line. So that was y equals x. So I'm just going to take the x to here, okay, and that's the upper. I'm going to put them in the brackets because there's always a chance of losing something from here with getting the signs worked out in the wrong way. Right, so the lower curve is this red one, and the lower one is this curve here. Okay, so I'm going to have x squared minus 2x going in there. And that's me kind of set up to do my work. What I like to do is to tidy that up a bit. So what I'll do is, I'll have 3 and 0, and I'll just multiply that out by minus 1, okay, because there's a minus there. So that'll be minus x squared, and that'll be plus 2x. And I'll gather the x's together. And you can gather them in any way that you want. So what I'll just say is I've got minus x squared, and that's going to come over there, plus 3x. Could be the other way around, it could be 3x minus x squared if that's neater for you to work with. This is in a form where I can integrate, so I need to integrate this part here, start with a square bracket, and I'll integrate this by increasing the power by 1 and dividing by the new power. Increase the power by 1, so that's a 1, that's going to go up to 2, dividing by 2. And the limits 3 and 0. Now what I'm going to do is I'm going to substitute my limits into this part here that I've just integrated. So I'm going to have 2 brackets, take 1 away, and that will be the lower limit. That will take away. So 3 is going to go in here. So I've got minus, that's 3 cubed, all over 3, plus 3 times 3 squared, that's the 3 squared going there, all over 2. Over here, I'm going to put the 0 into that equation there. So that's 0 cubed, all over 3, plus 3 times 0 squared, all over 2. And I know that's going to work out to 0 at the end there, but I'm putting it in as a substitution. Right, to work this through, what I get is I've got minus 27 over 3 here. I've got plus 27 over 2, and this part here works out to be 0. If I put that into my calculator, or I work it through as fractions by trying to make the numbers balance to 6, well, what I can get is 9 over 2. You'll have your calculator, so I'd use the calculator for this question here. Again, it's the area that I'm working. I don't know what the units are, so I'll just call it units squared. And that's the question complete. Right, let's see how question 5 is marked here. So question 5 will be marked first of all for, let's see what we go for. I'll go for 1 mark for integrating and setting up the integral sign and putting the limits on. And I would again like to see this here. I don't want to see that going missing, although you won't lose it for that there. I'd like to see the upper minus the lower appearing with the integral sign, or seeing it in this fashion here. So I don't need to see it as upper minus lower, I can see it as the equations if they're put in correctly like that. I'll then get a mark for, we'll go for this part here. So gathering everything together to integrate it properly. Next mark for integrating correctly. Next one for substituting the values in, that'll be this line here, and finally a mark for getting the final answer. So that's going to be out of 6 marks. So the outcome here for basic integration, it works out to be 14 marks in total. You're required to achieve 10 of them. Do your best. Good luck.